Okay, so good morning everyone. Today, first I will discuss about the transition from IPv4 to IPv6, how the transition can be done, and next we will discuss about the user datagram protocol, that is the UDP. So first, we will discuss today about the transition from IPv4 to IPv6. Now we have three strategies present. These three strategies are dual stack, tunneling, and header translation. These three strategies are present to transition from IPv4 to IPv6. So the first transition strategy we will see is the dual stack. Now, what is dual stack? Now, until all the computers present in the world are converted to IPv6 transition, because until all the computers, there are computers present that are using the IPv4, but until all the computers present in the world are converted to IPv6 transition, till then the computer maintain IPv4 and IPv6, because all the systems that are previously assigned to the IPv4 are now till now didn't able to convert that whole systems to the IPv6. So that's why we have to maintain the both. So maintaining this transition is required so that we can simultaneously use that, and through dual stack we will use it. So how we can do that, we will see that in this dual stack, you see in this dual stack there will be the source present and a destination is present, and between the source and destination there is IPv4 stack and IPv6 stack, and also there will be the IPv4 system present and IPv6 system present. So when source has to send some packet to the destination, when the source has to send some packet to the destination, source will do what? It will contact to the DNS. I will explain DNS later on, but till now you remember that source will contact to the DNS. DNS is the domain name service. So source will contact to the domain name service and inquiry about the destination. So it will inquire about the destination. Now DNS will send some response, and depending on the response received, it will source will decide whether it will use the IPv4 or IPv6, depending upon the response. So if the response received is IPv4, let's say the response source inquire about the destination to DNS and it receives the IPv4. It receives that the response as the IPv4. Then the source will do what? Because here two stack are present, IPv4 and IPv6. Both stack are present. Then the source will send the packet. The source will send the packet to the IPv4 system. The source will send to the IPv4 system because it receives the response as the IPv4 using this IPv4 stack. And from here to the IPv4 system, the packet will pass to the destination. So if the response received is IPv4, then the source will use the IPv4 stack, and through this stack it will send the packet to the IPv4 system, and from IPv4 system the packet will be transferred to the destination. And if, let's say, if the response is received is IPv6, then the source will send a packet to the IPv6 system using IPv6 stack, and from this IPv6 system the packet will go to the destination. So this is the use of the dual stack. So this is the use of our dual stack. So it is the first strategy. The second strategy is the tunneling. Suppose we have two IPv6 system. Suppose this is an IPv6 system and this is also an IPv6 system. And the client is using the IPv6 and server is also using the IPv6. Now, between them, there is a region. That region uses the IPv4. That region uses the IPv4. Now, how we can send the packet? How we can send the packet? Because this is also using IPv6 and this is also receiving the IPv6. But between them, the region over through which the packet should be passed, it is of the IPv4 region. Then if such a condition happen, then we uses the concept of the tunneling. So we will use that like this. This is the tunnel. So we will use a tunnel like this. And this client will do what? This client will send the packet to the server via IPv4 region. Now from IPv6 client, IPv6 address will travel because this client is using IPv6. So that's why IPv6 address will go. But when it came to this IPv4 region, then the IPv6 header, this IPv6 header will be encapsulated within the IPv4, encapsulated inside the IPv4. So this region, it looks like that the address is going is the IPv4 because the IPv6 address, because if we have to pass the address through this region, then the address must be IPv4. So how we can do this? That because the address is IPv6, so the technique is we will use this IPv6 address, we will encrypt, not encrypt, encapsulated this IPv6 address inside the IPv4, so that this region think that the address is the IPv4, and it will through the packet to the and move the packet forward. So when it will move the packet forward and the packet will came here in this, the region, it will use the IPv6 because the server is containing the IPv6 address. That means this will, in that case, it will be omitted. This IPv4 header will be omitted, and we simply will use the IPv6 address because in this time the address is the IPv6. In simple words, we can say that a IPv6 packet is encapsulated in the IPv4 packet when it enters in the IPv4 region, because this IPv6 packet will be encapsulated within IPv4 packet, so that the IPv4 region will think that this is the IPv4 packet, and it will do what? It will move the packet forward. And when it will move the packet forward, in that time this packet will do what? This IPv4 region, because this IPv4 is IPv6 is encapsulated within IPv4. So this IPv4 will, what will do in this case, we will omit this IPv4. We will omit this IPv4 and the IPv6 address will go to the server. So this is the technique of the tunneling, because we cannot send IPv6 address over the IPv4 region. To overcome this problem, we will use that IPv6 packet to be encapsulated within IPv4. And when we will overcome or pass through this region, this will help. And when we will move forward, in that time, we will IPv4 packet for the header, we will remove it, and again the IPv6, it will become the IPv6 address, and this will reach to the IPv6 server. So this is the second strategy we use. This is the second strategy we say, this is the second strategy we use, that the concept of the tunneling. Okay, so clear? Till now it is clear?
Yes, sir.
The strategy is clear? Okay. Then the next strategy is the header translation. Now, when most of the systems are on the IPv6, because these strategies or transition came because all the systems, all the systems that are present, some system uses the IPv4, some system uses the IPv6. So between them, for making the transition, we should have to use this strategy so that the communication can effectively done. Now, if the first strategies we see that dual stack, then the strategy we see that the our tunneling. Now, third strategy we will see is the header translation. This is the third strategy, that is the header translation. Now here, when most of the systems are present on the IPv6, so that the most of the system using the IPv6, but some still uses the IPv4, then what we will do? Like here also you see there are two client present, client 1 and client 2. Now client 1 is using IPv6 and the client 2 is using IPv4. So how the communication should be made between them, because they are using two different IP version. So in this case, what we will do, this client will send the IPv6 packet and it will pass through the IPv6 region. After passing through the IPv6 region, it will go to the header, there will be present a header translation mechanism. Now, what is the purpose of this header translation mechanism? This header translation mechanism will take the input as the IPv6 and convert this input as an output. In input, it will take IPv6 address and it will convert this into the IPv4. So header translation mechanism is it will take the input as the IPv6 and it will convert it into IPv4. So if it convert it into the IPv4, then it will be easy for this client because this client is using the IPv4 address. So the packet will go as the IPv4. So this is the header translation mechanism. That header translation mechanism, it will convert. Now you can say that here if we use the IPv4 and here we uses the IPv6, then here the region will be used as the IPv4 region. So IPv4 address will be passed and the header translation mechanism will do what? It will convert this into this as an input. It will take the IPv4 address and it will convert this IPv4 address into IPv6 because in this time here it is using the IPv6 address. So this will convert it into the IPv6 address and the client will receive the packet. This client will receive the packet. So header translation mechanism is basically whatever it is taking as an IP version, taking as an input, it will convert it into the other version. That is the communication between them, what we have seen. So this is the transition between IPv4 and IPv6. And these are the three strategies present. So now if we move forward over the difference between IPv4 and IPv6, then this is simple. We will see this is the simple because IPv4 uses the length of address as the 32-bit. Already we have seen that it uses the 32-bit, whereas the IPv6 is 128-bit. Now, generally in the IPv4, address represent as the decimal notation. We use to represent the IPv4 dotted decimal notation. Basically, we use that. I have said that when in the IPv4, because this will compact the address, so that's why we uses the dotted decimal notation for representing the IPv4 address. And for representing the IPv6 address, we uses colon hexadecimal notation. Now, for IPsec support, that means IP security support. This IP security support is optional in the IPv4, whereas the IP security support is inbuilt in the IPv6. So that's why IPv6 is much secure. That's why because IP security support is inbuilt in the IPv6, whereas in the IPv4 it is optional. Now there is a packet flow indication present in the IPv6. With the help of flow level field, we have seen there is a flow level field present for the IPv6, but in our IPv4 there is no such flow level field present in the header format. So that means there is no such a packet flow indication present. Same as that checksum field is present in the IPv4, but checksum field is used for what? To check the error occurred. So checksum field is present in the IPv4, but the checksum field is not present in the IPv6, and there is a optional field present in the IPv4, whereas in the IPv6 the optional field present is none, because IPv6 uses the extension header. IPv6 uses the extension header. Now for IPv6, for IPv4, let's say for the IPv4, from address to MAC address, from converting the IP address to the physical address, we uses the address resolution protocol. We have seen that we uses the address resolution protocol from physical address to the logical address. But in the IPv6, it is replaced by the neighbor discovery protocol. In the IPv6, we uses a concept that we called as the NDP. This is called as the NDP. Now, this is known as a neighbor discovery protocol, and it is replaced by this. Whereas in IPv4, broadcast message is present, but in the IPv6, broadcast message is present as the special type of the multicast address. We have seen when in the description we have said that how many our addresses, or our, we can say that how many addresses, type of address space in the IPv6. In that time we have already said that there is the unicast address. We already said that there is the unicast address, multicast address, anycast address, but broadcasting is not done. But broadcasting is not able to done in the IPv6, and it defines the considered as a special case of multicasting. In IPv6, the broadcast messaging is a special type of a multicast address. And the total number of address, because here the total number of bits is what? The total number of bits is 2 to the power 32. So total number, total number of bits is 32. So that means the total number of address will be 2 to the power n. So 2 to the power n means total number of address space will be 2 to the power 32. Whereas in case of IPv6, the total number of address will be 128. So n is equal to 128. So that means 2 to the power n, that means 2 to the power 128. So total number of address space in IPv6 will be 2 to the power 128. So this is the difference between IPv4 and IPv6. Okay. So now we will move to the user datagram protocol. Already in the previous class we have seen about the TCP. So in the TCP transmission control protocol, so today we will see about the UDP, user datagram protocol. Now UDP is the simplest protocol. UDP is basically a very much simple protocol that involves the minimum amount of communication mechanism, and it is the connectionless, unreliable transport protocol. Now, if we compare it with TCP, TCP is the connection oriented and reliable protocol, but UDP is the connectionless and unreliable protocol. Then you may ask a question that why we use the UDP? Then because it is connectionless and unreliable, then what is the purpose of using this UDP? We can use the TCP for that, but in some cases we use the UDP. Because if we have to, a small amount of data we have to transmit, if we have to transfer small amount of data with very high speed, small amount of data with very high speed, then we uses the UDP concept. Because TCP is connection oriented and reliable, but it will take much time. So for that, if we have to send some amount of few amounts of data with a very high speed, then we have to use the UDP. Now the features are almost same, some are different from TCP. Like if you see in the TCP also that it is a process to process communication, for UDP also it is a process to process communication. And it is done with the help of the port number. For TCP also it is done with the help of the port number. And it is the connectionless service. It is the, whereas features of the UDP is the connectionless service, and it is also unreliable. It is also unreliable. And flow control. If you remember, there is the flow control mechanism present in the TCP, but in UDP, there has no flow control. Now, we every time we are saying that it is connectionless service, we are saying. Now, if you remember in the TCP, there is a thing that we called as a three-way handshaking. Previous class I have discussed that the three-way handshaking. So basically in the three-way handshaking is what the connection is established. That means first there is a client present one side and another one is the server present. So client is sending sync packet or synchronous packet. Client is sending synchronous packet with a sequence number. After receiving this, the server will do what? Server will acknowledge that particular sync packet which it received with the sequence number plus 1. So the acknowledgement number will be sequence number plus 1. And it will send its own sync packet to the, with a sequence number to the client. Now, after receiving this, client will acknowledge that with the sequence number that is present, it will give the sequence number plus 1. That will be the acknowledgement number for the packet which it received from the server side. So that means 1, 2, 3, 3 communication is done. Now, after this 3 communication, the data transmission started. This is the connection. That means this the three communication which we done, this is for the making the connection. So first the connection is established using this three-way handshaking, and then the data is transferred. But in UDP, there is no such concepts. UDP, we do not have to send like sync packet, then again from this server side to the client side, the sync packet and the acknowledgement to the sync packet it received from the client, and the client will again send a packet to the server, that the acknowledgement of the sync packet of the server. It will not do like this. Directly communication is made. So that's why it is connectionless service, that before sending the data, no connection is established between client and the server. So that's why it is unreliable, because no client also didn't able to know that whether server is ready or not, and server is also didn't able to know that whether it is ready or not, because connection is not established. We are sending the data from like that. So that's why it is unreliable. But there, that in the TCP, it is reliable. In that case, it is reliable. So this is the difference and the features of UDP. Now, for the flow control, we have already seen in the flow control is present in the TCP. So the flow control that is present on the TCP, that the sender TCP will do what? Sender TCP will send packet so that sender TCP will send packet to see that it can effectively process the packet or not. This is what sending the TCP done, that it will see that the packet can be, to control the flow of data, we can see that the packet is the packet can be sending side of the TCP control how much packet, or say how much data it should be sent, so that the receiver can easily accept the data. Receiver can easily accept the data. That means it is checked, but in this no flow control present, so it will send data like that. That's why it is unreliable, because it doesn't know client or the server, both the source and destination, both. It will send the data, but how much data it should be sent so that the receiver can easily process it, it doesn't know that. So that's why UDP has a no flow control. Error control also, UDP has a no extra error control mechanism. extra error control mechanism is not present in the UDP, except in the header format. In the header format of the UDP, there is the checksum present. In the UDP, like the TCP format, also TCP header format, there is in the fields present. In that, like that, in UDP also there is the checksum field present. This is only this checksum is used for entire user datagram, but no extra error control mechanism. No extra error control mechanism is not present in the UDP. And congestion control also, there is no congestion control mechanism present in the UDP. Now we will see the header format of the UDP. Now UDP we called UDP packet is called user datagrams. UDP packet is called the user datagram, and here there will be two parts. It is divided same like that in TCP also. It is divided into two parts. One is header and another one is data. But the length of the header, if you remember, the length of the header in the TCP is 20 to 60 bytes. But here the header length is small. Here the header length is small, only 8 bytes. Now, if we see the header format, this is also very much simple. This header format of the UDP is very much simple. You see, only 4 fields are present. Only 4 fields. This 4 fields, 1, 2, 3, 4. Only the header format of the UDP is like this. Now, the first field that contains the source port number. Now, you already know that source port number is what? The port number of the source, or we can say the application that is present on the source, that port number. Or in the case of destination also, in the case of destination port number is the port number of the destination, or we can say the port number of the application of the destination. Port number of the application of the destination. This is the destination port number. And the third field, this third field is total length. Now, total length is what? This total length, it defines the total length of the user datagram. That means this user datagram, total length it describes. That means header plus data, this total length is described by this total length fields with consisting of header plus data. This is the total length. And the checksum is used to check the error of header with header plus data. That means both of this error, checking the error, the checksum field is used. Now both of this are, this source port number is also 16 bits. This is also 16 bits. This total length is also 16 bits. This total length is also 16 bits. And this checksum is also 16 bits. So the checksum field is used for what? It is used to check the error of the entire user datagram. So entire user datagram means entire user datagram means it will consist of header plus data. So checking error of this total, we uses the checksum field. So this is very much, this header format is simple. We are seeing that in TCP there is much more, the header format is much more complex. But here in this UDP, the header format is very much easy here. So now this is all about the UDP concept. Now after this, this is a very, we can say this is a very much important question, and this question is very much important, this difference between TCP and UDP. So we will discuss one more time about this, that what is the difference between them. Already, if you know in the TCP and UDP, if you the total, from this total you will see this, that the differences between what in these differences, based on the characteristics or the description, we will difference between the UDP and the TCP. Now first, the characteristics is general. So using the general characteristics, we will differentiate between UDP and TCP. Now UDP is what? UDP is very much simple, high speed and low functionality protocol. This is very much simple UDP, and its speed is also very much high, but it is a low functionality of a protocol. That means we cannot use it in everywhere. Only when we have to send a much amount of data with a high speed, then we uses the user datagram protocol. But in comparison of to the UDP, TCP is the full features, because all the features are available in TCP, and it is also much reliable, but much reliable data transfer. With, if we compare it with UDP, then TCP is the full featured reliable data transfer occurred in the TCP if we use the TCP. And then for, if the characteristics is the communication setup. For communication setup, UDP is a connectionless. We already seen and already described that a connectionless means what? That three-way handshaking is not present here. So before transferring the data, no connection is established. But in TCP, the connection is established before sending the data. That's why it is the connection oriented. Then data transfer to the application. The UDP uses the message-based data to be sent. UDP uses the message-based data to be sent, whereas TCP is for continuous stream-based data. Means the stream-based data continuously is sent. This stream-based data is sent in the TCP. If we check using the reliability, that it is unreliable. We already know that UDP is unreliable. Because why this is unreliable? There is no such communication is happening before data transfer. So that means what? No packet transferring is done. So how acknowledgement will come? There is no way that acknowledgement is come. So that's why if the acknowledgement is not come, then we can say it is unreliable. But TCP, in the three-way handshaking, we have already seen the acknowledgement is received. So that's why TCP become more reliable. For retransmission, it is also the same. If acknowledgement is not received, then how the retransmission can be done? If the acknowledgement, if any of the acknowledgement, positive acknowledgement or negative acknowledgement, if we received any between these two acknowledgement, if we received any acknowledgement, then we can say that retransmission is done. That means if negative acknowledgement received, that means the data is not properly gone to destination. So that means we have to retransmit that packet or the data. But if the acknowledgement is not received, then how can retransmission is possible? There is no way that retransmission is possible. Whereas for TCP, if the data is lost, then retransmission occur, because acknowledgement is receiving. In that time, it will send NSEK. NSEK means negative acknowledgement. So if negative acknowledgement is received, that means there is some problem happens in the destination end. So source will again send the data to the destination. That is the retransmission. For flow control, UDP has non-flow control. No flow control is present in the UDP. We have seen. But in the TCP, the flow control with the help of the sliding window protocol. With the help of sliding window protocol, the flow control is happened. Next, the characteristics is overhead. The characteristics is overhead. So for this, we can say that it is very low overhead. For UDP, it is very low overhead due to less available of extra features. That means here in this UDP, extra features is not available. Very much less extra features is available. But in TCP, the overhead is much because it has also less features, but more than the UDP, higher than the UDP. TCP's overhead is also low, but the overhead of we can say UDP, it is much more in the TCP. And the transmission speed that I have said, if the characteristics is based on the transmission speed, the UDP is very high. UDP has the very high transmission speed, because if we have to send data in a small or a few times, the amount of data in a small time, then its speed is the very high and it works with properly. But TCP has also high speed, but it is lower than the UDP. It is lower than the UDP. And the last thing is the characteristics that the application that uses the protocol. Now, DNS, domain names service, BOOTP, DHCP, dynamic host control protocol, which we have in the lab classes, we have seen dynamic host control protocol, SNMP, all of that like multimedia based application. This all are the multimedia based application. So the multimedia based application uses this UDP. And FTP, Telnet, FTP file transfer protocol, Telnet, SMTP, then DNS, HTTP, hypertext transfer protocol, and so on, uses the TCP. So this is the difference between TCP and UDP, and it is a very much important question. So always remember these points. Okay. Here I have not used you can also write two things, that is the error control, about the characteristics, error control and congestion control. That error control occurred in this, didn't occur in the UDP, but it is occurred in the TCP. Same as that congestion control, it doesn't occur in the UDP, but it occurs in the, we can say occurs in the TCP. You can say that also, but I have not written that you write there. Okay, so this is all about. If anyone has any question, do you have any question? सबको समझ में आया?
Yes, sir.
Okay. So this is all about our TCP UDP concept. So in next class, the last